Testing, testing, 1, 2. Well, let's continue. This is going to be a fast series off of Jake Hebbert's reflection on nature of code and me reflecting off of him. Just amazing, simple scripts. Take a look at this one again. I've paired it over here on Grasshopper. Need to jump out of here and get out of probably the map. There's our nice little rendering of a baked form that I can grab. Really easily small script playing around with geometries. Be nice to change the shapes of this into a bridge or into something architectural, but a nice little tool pattern. Don't use the Voronoi much. I certainly don't. But once again, I had that little simple script here, and you can see it was a basic script of grabbing, very similar to what you see here. Importing, I did import a math. They imported a random. They set up a list. They name that list, and he calls it rand. They update and append that list. I updated mine with cool, and we put that to the output. They put it to the list. I put it to a list. So very similar. I keep seeing this coming up again and again, and I'm getting my head wrapped around it. So that script's there. They've changed the count from T to C. They've changed their variables. They had to put in the variables on your node. I'll show you how that changed as well. So let's just close this out for now and take a look at what they did. So basically went in here. I'll grab all this geometry, and I probably should turn this one off because we don't need to be seeing that. So it's awkward to do that. That should disappear. I'm not sure why it's still there. I guess I have another thing up. Strange that my Grasshopper script's still kicking around there. Anyway, maybe because I've got it on show. There we go. So we're just taking a look at what's there now. Let's take all our geometries and put the visibility off. And here's our Voronoi pattern as it's being made in all its glory, maybe specifically to what we want. This was the initial code, and there it was. I showed it at making a list, walking through the count. They've imported random, they've seeded that random, and they put in a Gauss function. And what's nice is you leave this on help, and if you're typing Gauss, I guess dot, it would come up down here, or whatever you're typing in comes up down to the help menu. It needs a couple of attributes, so it's going to need mean and standard deviation. Simple script to follow through their tutorials. Let's close that one out and realize that in here, you seed it, you count it, you mean. These two are integers. This one has been set a type hint to float, I believe. Yes, and the other one's float. And they've imported those into, this is in case you want to decompose other points and have many points, maybe pulling the patterns away. But the standard deviation, you have a lot of control in the X, Y, Z. So not only can you seed each one and get a different pattern as you go through, keep in mind it's actually plugged through the Voronoi and the bounding box, and it's trying to build this form along with this form. You can see this one's clustered and in control coming right out of the points. This is one that you use your bounding box and take it through a populate 3D and it becomes more uniform blocks of what you might want to do. I think this pattern is much better, so I'm just going to take these to disable, and I'm only going to be using this one, which I really like as a pattern to make. And what happens is in the XYZ, you have full control keeping the Gaussian mean close to center, but you can change that if you want to move that point. And they walk you right through beautifully. And another thing I did on the side was I just thought it would be fun to preview on. I always like going in and just playing with the points and thinking about those different patterns. So as these point patterns are being controlled, I can go in and I can play with my geometry through a variable pipe. It doesn't have to be a variable pipe, but as I see this differently, or say I take the count down on the Z direction, you're going to realize that it gets real flat. As I pull it in thin on the Y factor, I can pull that down and make that a much thinner script. It's jumping pretty fast, as you can see there. Got a big count on it, you make this thing huge. But once you understand your data as points, then you're going to get back into Grasshopper and you're going to have fun with all these other tools that try and drag you into, which is the meshes and the solids and the transformations and all that. But really nice little box form here. I think that's just fantastic. Take your cells, send it to a bake. Don't join them, and they're baked pretty fast. You can leave that script, and now you have a very cool object that you can lift and pull, take apart, enjoy what it looks like. Nice little script. And honestly, the Python script with a few, using the Gauss function, which is going to use quite a bit through these walkers, that's the power of using Python. You don't have to script that. You don't have to define that all by node-based scripts. Once you find patterns that you like, take your little snippet tool, grab this one up here, possibly, and I'm going to give credit to Nature Code and Hebbert, so I'm going to grab that, go to my snipping tool. I'm going to click on it and say, listen, I want Hebbert and slash nature of code, and I'm going to call this script bounding box 001, and we're going to say save that, and there we go, done. And now whenever I want to just grab a little funk and throw it into my script, we're going to close this one out. We're going to save this one. We'll save it as another one, but let's say I wanted to save that file save as our next script coming down the pipe, which is 132. You could come in here, you could save, you could get rid of all this quickly. And it's just a little tool I use that, I really am not trying to build stuff from scratch every time I come at it. So I could definitely go in here, I could find my nature of code, Hebbert and nature of code, go to bounding box, drag it in, and there it is. And it should be popping in there somewhere. Sometimes it displaces over there, and there we go. Got our whole form in again. We can get rid of our baked in form, and we can start again and do another bounding box, whatever we want, playing with that size and scale of what's happening. Really nice script, 6 minutes flat. Get in there, watch the videos. You don't want to start Grasshopper. I really have to recommend, don't start Grasshopper with a blank document and just start in here with a geometry that's given to you under the surface. You've got to dissect and think about what that is, and to bring this all the way back down to the attributes and forming points, and realizing what they are as maths and sets. And I haven't even gotten into dealing with Python and getting into data tree information again, and playing with path mapper, split tree, and relative items. And the more I go into this, the more wonderful the world is, the more my brain starts clicking. I feel like I'm getting somewhere that maybe other people aren't, or at least I haven't been. And yeah, and tucked away in here, I think there's actually something else underneath there. There it is, kind of daisy-do back and forth from that line form that was being piped. I think there's a problem with the, no, it's there. And then this form on top. Let me just take that, put disable that, and there's my other form underneath. I'll pipe like a weird bagpipe inside of a box, and I might do a Boolean difference on there, but your script's going to start slowing down. If you depend on that surface and all that, and you're getting frustrated and you're having trouble with meshes and solids, go back to this code, go back to the scripts, go back, know what's happening. And if you do get lost a little bit into something like other people's libraries and other people's functions, like Gaussian, then go read a book on Rhino and Python and Grasshopper and math, and dig deeper into that. Anyway, thanks very much for watching. I'm pretty excited about this whole shenanigan thing. I think it's just fantastic. Thanks for